Hi everyone, Miss Hampton here. So I'm here to explain your independent practice, and I'm going to zoom in so you can see this a little bit better. So this is the Seasons HyperDoc that we've been working out of. And a HyperDoc, when I use a HyperDoc, it's a good indicator that there's a lot of resources we're going to be using. And this just helps put them all in one space so that you're not like all over Google Classroom. As much as I organize Google Classroom, it always doesn't work out that well. So I like HyperDocs when I'm using a lot of stuff. So as a class, we answered the Bellwork question, how do we experience seasons in Joliet, Illinois? And if you have a family member, or maybe even if you've traveled to another country, what are seasons like there? And we kind of discuss those, what makes them the same, what's the different, what do we think would, drive that change or difference that we might see, if we see a difference at all. So that's what we discussed a little bit. We went ahead and watched that YouTube video that explained seasons. We saw that the tilt of the earth was the big responsible force for that phenomenon of seasons. So that tilt of the earth is actually what's responsible, and not the elliptical orbit that we talk about in class. We think that sometimes, we're further away from the sun, that's what gives us our seasons, our cold season. Well, we found out that that's not exactly it. It's our tilt. Then we discussed our NASA reading, which reinforced this, and we did our breakout rooms, the 3-2-1 activity, and discussed this a little bit more in depth. But I'm going to go over what your independent work is. We've worked as groups, we've done breakout rooms, and we've discussed a lot, but now you're going to do a little bit more independent practice. So we're going to spend some time in a simulator, and I love simulators. In science, we use simulators a lot. We love simulators. They're kind of like a model. They help us to see something that we can't easily see on our own. So we kind of make something that helps us to envision that process or that phenomenon. So here we're going to use a simulator that's going to look at, and we're going to focus on 4 places. Anchorage, Alaska, which is in the northern hemisphere, very northern hemisphere up here. Chicago, Illinois. No, I did not choose this interactive because Chicago, Illinois was on here, but I thought that was awesome, and my favorite color is green, so I thought that was even better. Then we're going to look at Quito, Ecuador, which falls on the equator, and then Melbourne, Australia, which is all the way in the southern hemisphere. Those are the 4 we're going to focus on. Some of these might look familiar. You might have seen this in geography, the Tropic of Cancer, Tropic of Capricorn, and the equator. We're going to look at the equator, but we're not going to look at the tropics too much. They are a good point of reference. You know, the Tropic of Cancer is in the northern hemisphere and Capricorn in the southern. And what's nice is they have this nice color coordination that we'll see in the actual simulator. So I'm going to go ahead and click it. So I love simulators, and this one is really cool, but sometimes we do some wacky things, like for instance, the sun. You may notice it is very small. The sun is not very small, like in real life. It is not small at all, and the earth is not bigger than the sun. But to give us a better detail of the earth, they did that, because the size of the sun makes no difference for this interactive, and this helps us see the detail. So, if you're wondering why the sun is so small in comparison and why it's inaccurate, that's just a representation. So you'll see this side view, and then down here you'll see a top view. So you can see the top, this would be the North Pole that you're seeing looking down. And this is just a top view of the earth. So right here we have the different months, and this is cool. If you hit the arrow, so right now we're in January, February, March, and April, May. So that changes the months. Then down here you'll go to tropics and equator. Do you want to show them? This is a really good reference tool because you can see the tilt of the earth. The red right here is that equator. This is the Tropic of Cancer, and this is the Tropic of Capricorn. So this is just a good reference to see that, yes, there's definitely a tilt. And then you can move it around, and you see that that tilt doesn't change. The Earth is moving around in its elliptical orbit, but that tilt is staying tilted to that 23.5 degrees. So you can move it all the way around, and that tilt is going to stay the same. But what's really cool about interactive is this can change it to a 0-degree tilt. So what if the Earth were up and down? It's not, but what if it were? And that's what a question you're going to answer in your comprehension questions, but that's how you would change it. Most of your questions are going to have you remain at a 23.5 degree tilt because that's what we really see. And then you'll change the months around. But then I'm going to go ahead and hide the equator for right now. And I'm going to move it around so that you can see it a little bit better. There we go. Put it right there. So you will see, you can go down here under Show City, and it shows the color because each one has its own color, remember, from that first page. Anchorage, Alaska has this pink, so you can see it lit up right here in the very northern hemisphere. And you can put in Chicago. There we are. And zooms by, so there we are. It zooms by so fast. Quito, Ecuador, which falls on the equator, so a little bit on the top of the northern part of South America. And then Melbourne, Australia, which is yellow, which is right there. Yeah, so this shows you those different locations on the Earth. So if you move over, and right now we're in August. So in August, Anchorage, Alaska is getting 15 hours of daylight. So that's how much sun they're getting. If we move it around, you'll notice that these numbers are changing. So for example, if I unhighlight all of these and I only keep Chicago, Illinois, because that's what we're pretty darn close to, you'll see that the sunlight right here is not much. This is as much sun as we're getting that day. So this shows you we're only getting 9, almost 10 hours of sun. But if you go into December, it's less. We're getting 9 hours. And the average temperature is 27 degrees. So this is in December, and 9 hours and 10 minutes. But when we go to January, remember what's in December, we have our winter solstice. So we went from that point, that winter solstice is the day where we have the most night life. Like we have that least amount of daylight and most night time. So we have our really long nights. So right now we only have 9 hours. The remaining of that 24 hours is in darkness. So that's a lot of our day. We're only getting 9 hours of sunlight. That's not a lot of vitamin D, guys. We got to get our vitamin D. So you got to make the best of those 9 hours. What I always think is crazy is Anchorage, Alaska only gets 6 hours of daylight in January. Can you imagine only 6 hours? My plants, they would not do so well. And that explains why certain plants in Anchorage, Alaska aren't going to grow as well. Or they're going to have different plants that can handle only 6 hours of sunlight. So this is showing those exposure to sunlight. You can see it. So as you turn it around, it's going to change. See, the sun is showing on more. So this is in May. In Chicago, in May, we have 14 hours. So we have more than half of our day in sunlight. And Anchorage, Alaska has 17 hours of sunlight. So they're in the sunlight a ton. So this is kind of showing that information to you as you kind of highlight them and you can find it and change the months. So I'm going to go ahead and show you what you're going to use this information to answer, and that's these comprehension questions. And I'm going to go ahead and model the first one to you. Let me let that doc upload, and then I'm going to make it bigger so it's easier for you to see. So you'll see the first 6 questions, you are going to use the simulator. The simulator is going to help you. So the first part of the question is going to tell you how to set up. So selecting the 23.5 degree tilt. So I'm going to go back to my simulator. I have it on 23.5. It's highlighted in orange here. Select Anchorage, Alaska in January. So I only want to see Anchorage, Alaska, and it said January. So I'm going to go ahead and change it to January. There we go, January. How many daylight hours does Anchorage, Alaska experience? So if I go down here, Anchorage, Alaska, and I'm on January, and I got the tilt on, it'll tell me my daylight hours. So it's 6 hours and 27 minutes. So, 6 hours and 27 minutes of daylight. And that's my answer. I'm going to probably tab back just to make it look a little bit nicer. So that is what you would expect to see as an answer for the first question. And then you're going to do pretty much the same thing. Some of these you will change around a little bit, you might not use the tilt. I know at least one of these questions you will not use the tilt. So here, number 6, no tilt. So you're going to remember that that means you want to go to 0 degree. Remember, degree is that angle. We discussed what a degree means in science, and that means that angle. So right now it's straight up and down. There's no angle. Now there is an angle of that axis, 23.5 degrees. So that is your comprehension questions. And then you can go down to the last 2. This is going to be worth 10 points altogether. You have 8 questions, but some of these have 2 parts. So altogether, this is going to be worth 10 points. Your enduring questions, this you could find the answer to with help from the simulation, but also some of the reading. So that's where you will find those. And there's just 2 questions there where you won't be using the simulator. It might help to use a simulator, but it's not required. So that is the comprehension questions and the simulator. If you have any questions, you can put them in Google Classroom or email me directly. The next thing I want you to take a look at is our exit slip. And our exit slip is really just for a participation grade. And this is either you do it or you don't sort of grade. So our exit slip is to watch this clip from the movie Radioactive. So Radioactive is a movie about Marie Curie and how she found the 2 elements that we have, plutonium and radium. And this is kind of her backstory on how she did it. It's a great movie. It just came out a year ago. It's very good. So once you watch this clip, consider how research and theories were presented to scientific societies. This is a 1-minute clip, and it is actually, that's its entirety, is her in front of a scientific society speaking to them and presenting her findings. And back in the day, a woman would have to usually be accompanied by a male because a woman couldn't speak in front of a scientific society by themselves. She kind of broke that barrier. So it's kind of a cool example of, seeing some equity of a woman or a minority speaking in a scientific society. So thinking about our new understanding of how the Earth's tilt is responsible for seasons, we just learned that it's the tilt that is responsible for seasons, not its orbit. How would you present this information to a scientific society today? So if you were going to go stand in front of a scientific society and you said, hey, I got some belief here that I think that it's really the tilt and not the orbit. You are going to write a 5-sentence paragraph in your Google Exit Slip doc, or you can explain it in a breakout room in our next class, or you can video record yourself. You just share the link with me. But you don't have to, if you decide to video record, you don't have to show your face. You can just record your voice if you want. And you're going to explain what illustrations, models, or even simulations you would use and what information you would include. So you might decide to show that simulation to explain this is what it looks like if we have seasons and if we don't, with the tilt and with not. So you could show that. You could do a lot of ways, or you could just explain it very simply. What pictures might you use? Would you use a model? Would you take the globe like I showed you in class and use the globe? There's a couple options there. This is really just a participation grade, so you have free choice, and you just need to make sure explaining how you would explain it and what exactly you would explain. So if you have any questions, go ahead and shoot me an email, put it in Google Classroom. There are other students who might have the same questions, so feel free to ask. Thank you, and good luck.